So, someone confirm that my screen is visible. Okay, perfect. So, today's lecture will be, I believe, the last one in this Rolling Scopes School iteration, and it will be dedicated to design patterns. So, again, today's lecturer is Dmitry, and the agenda is the following. We'll review what is design patterns and why do we actually care about some abstract things like design patterns. Then we'll review three of the main categories of design patterns: creational patterns, structural patterns, and behavioral patterns. We'll dive deeper into each one of them. And we'll also review some examples, because the design pattern is already a bit like abstract topic, as I mentioned. So the hands-on experience will always be a good way to actually understand them. So we'll start by reviewing what is design patterns. And as the definition goes, design patterns are typical solutions to common problems in software design. Each pattern is like a blueprint that you can customize to solve a particular design problem in your code. This is like saying that all the problems that you're going to face are already solved by someone. And as a typical programmer would say, first, if you encounter some problems, go to Stack Overflow and try looking for a solution. With design patterns, it's mostly the same. When you encounter a situation, not necessarily a problem, some errors, etc., first thing you do is that you're trying to categorize the problem, the issue you're facing, or the task you're faced with by looking at what are the domains, what are the ways that commonly people are solving the same kind of problem, and that brings you to the already defined solution for that, and you just repeat it, or better say, implement it into your solution. So the way to look at design patterns in software is like it's essentially the same as you look to different kinds of architectures all around you. So design patterns are something that is inside that architecture that distinguishes this kind of architectural design from other designs. And what is commonly seen in all the buildings, for example, is the entrance, and as a way to go inside the building, or maybe a set of windows or set of floors that allow you to have an overview of the surrounding inside a building, or maybe have a more compact way of living on the area, so that you are not restricted to one floor and occupy the much more diverse territory. So in software design, it's almost the same, is that you're actually looking for a typical solution of the problem you encounter, and then you're applying the same problem, but also when already applied solution is discussed in the team, you can easily use those names, the design pattern names, to communicate with other people within your team. So, for example, when you're discussing some like state management in React, you can actually use this kind of set of words, state management. Are we going to use the state pattern? One developer asks, and then and the other one is like, no, we're going to use something like I don't know, streams. And you're both familiar with design patterns, and that makes the communication is much easier instead of actually going into details by asking someone like, "What do you mean state pattern or memento pattern? What do you mean prototype? What is that? What piece of code are you calling prototype?" So design patterns are also not just the ways you write your code, but also about the communication. However, um, I need to mention that the design patterns are not necessarily a good thing, because once a developer matures enough, grows um, some hands-on experience, I should say, um, he goes and learns about the design patterns. After learning them, after realizing that he was surrounded by design patterns all his time before he learned design patterns exist, um, he realizes that uh, he can apply, or she can apply design patterns everywhere, like in every case. Before actually trying to solve the problem, he thinks about the particular way how he can or she can apply the specific patterns to the code instead of actually solving a problem. So before thinking about how to solve a problem, people start using patterns just because, and it's actually a problem. Um, Also, some might say lots of like really smart guys who are veterans of the industry, they think that design patterns are patches on the programming languages. So, for example, if some programming language like um, JavaScript does not support typing, introduction of TypeScript is not a really good solution, but an indication that JavaScript is less of a language compared to something like C Sharp or C++. And that's really thing to debate about. However, knowing design patterns and knowing the ways to apply them is um, most of the time, I should say, with like 100% of the time, is really beneficial to a software engineer. And this is what we're going to learn today. So, the first set of patterns are creational patterns. Before you go to the design patterns, I should mention that the whole area of design patterns, of ways we can solve the problem, can be divided into several set of set of areas of expertise. We can put it like this. And as I mentioned in the agenda, these are creational, structural, and behavioral. So the whole set of design patterns started with a few guys, so-called Gang of Four, that I can show you the link. For example, this is the Amazon link for design patterns. They're a very famous book. It's like one of the books that most of the developers think they should have on their bookshelf all the time to just catch some dust. But anyway, the Gang of Four book, Design Patterns, by these four guys that were inspired by a work of the actual architect for buildings. They wrote a book about 23 patterns that were divided in those three categories, like roughly, and they focused on different areas. For example, creational patterns. They're focused on how to create something. Structural patterns are about how to structure code or files, and behavioral patterns come after you create something or structured your file system. They are actually about how to do something. So we start with the first one, which is creational patterns. They provide various object creation mechanisms which increase flexibility and reuse existing code. So the concept of object, as you might know, the object-oriented programming is a thing. Nowadays, it was a thing like 10 years ago. And these guys, they basically uh, mm, based design patterns on top of object-oriented software, as it says in the title. And in object-oriented software, objects and the ways you create them is a central thing. So, and as you might know, JavaScript is all about objects also, like everything is an object, but um, the Gang of Four brought the whole creation of objects to a design level, and they came up with various ways you can create those objects. And these are the ways like prototype or class in the classical programming language. So in JavaScript, we have prototypes, and it's all about how you how you create a template for your objects and then reuse it. The constructor builder pattern is about how you use maybe a set of templates, for example, to create a new template out of it. Singleton pattern about how you decrease the number of templates, or I should say the instances that can be created from a template. And the factory is all about a step higher above the creational process, how you create something from a template or a set of templates by following some conditions. And the abstract factory is even a step higher, how you create, depending on the condition, how you create a factory that then creates some set of objects from a set of templates. So to make it a bit more interesting, some time ago I created a repository that contains all these patterns organized in a very simple manner, like a bunch of HTML files that execute some set of JavaScript. For example, if we go to the Creational Patterns, we see that all these patterns are just connected to the HTML just by appending them to the bottom of the file, the bottom of the body. And that gives me an ability to write JavaScript code that implements those patterns and executes them and hopefully outputs something in the console. So let's take a look at the following website. So these are the patterns that we have. It has a fancy little carousel. And if we go to the Creational Patterns, we see that there are a number of patterns and basically the same thing, the same patterns that I mentioned already. And we start with the prototype pattern. So a prototype pattern is, as I mentioned already, a templating pattern. So you create a template that would be reused after that in a number of places in your code. And there's also a official documentation definition that says the prototype allows us to define a blueprint for a specific type of item and then reuse it by creating a new object from that class. Alternatively, you specify the kind of objects to create using a prototype instance and create new objects from the skeleton of an existing object, thus boosting performance and keeping memory footprints to a minimum. So in object-oriented programming, unlike JavaScript, which is based on prototypes, classes are actually non-existent while you're executing in runtime. The objects that are created based on those classes, templates, are the things that exist in memory. So instead of actually creating lots of similar-like looking objects every time you need them, defining each field and et cetera. In object-oriented programming, you define a class that then creates an instance of that object. So we can follow the Eddie Osmani. Eddie Osmani is a very famous guy in the JavaScript development community. And he has a really nice book. It's published in O'Reilly, but it has a section on their website that explains in details about the every pattern that I use in this small website. If you're interested, you can follow all the links. And also, I can mention that the same thing is available on my GitHub account. So the JavaScript design pattern is actually deployed in the on the GitHub Pages environment. So it has the same thing. You can just click around and see the same pages that I'm seeing here. So anyway, let's go into the code. So when I say that we are using Blueprint for prototypes, what I mean in the context of JavaScript is actually two things. The vanilla, or I should say the newly vanilla way of creating classes. So we define a class, car, some constructor that gets executed when you type a new word, and some methods that you want to share between the instances. And then we're creating an instance. So it's straightforward. Prototype class pattern is about creating this kind of objects or classes. You can also do a functional way. So you create a function, you enrich its prototype by defining some functions, and then the same way you're using new word. Or same thing, but in a pure object way, since objects are things in JavaScript that it gets created every time or like used every time you use JavaScript. So same thing, we create an object. It's actually a thing in memory. So this is where we diverge from a typical object-oriented languages like C, where we actually have something in memory in JavaScript instead of actually having a blueprint like in class. And then with the same thing, we make it a prototype for some entity, and then go and do fancy stuff with it or use it. So then we have a constructor pattern that is a bit different. So as you see, we're not having a prototype necessarily. So in object-oriented languages like C, we're not talking about class and its instance, as in this case. We were talking about some instance or class and then another class or another instance. So it's like a extent or inheritance sort of thing. So when you ask to distinguish between the prototype or class pattern and the constructor builder pattern, always remember that this is about class and instance relationship, and this is about class and some other class relationship. And the definition is follow. The constructor pattern is one step further from the class pattern, where we leverage a class created to initiate a new extended class from it. Or an object constructors are used to create specific types of objects, both preparing the objects for use and accepting arguments which a constructor can use to set the values of member properties and methods when the object is first created. Lots of words, but don't worry, we have some nicely written code that can help us. So, as I said, we have a class, a one class, and then we have a more specific class for our use case. So this is a builder pattern. So whenever you see an inheritance thing going on that uses some super keyword and then extends or changes the base class properties, this is a constructor or builder pattern. So we have a builder class. This is a builder, and this is like a consumer or like structure that gets that builder used. So you can think of a builder as a way to create things. So a builder pattern also applies to something like you can create new objects, or for example, when we're talking about front end, this can be changed to the creation of some kind of tag, image tag that gets src alternative tags and maybe some class from the constructor, and then the constructor returns that image to you. So every time you're building something programmatically, this is about the build department, especially when there is an like inheritance going on. Okay. So next one is a singleton pattern. So a singleton pattern is different from the previously mentioned patterns, is that it gets some, it saves some state inside of it, and it remembers whether it was created, like instantiated already or not. So a singleton pattern, which the name is actually a good explanation, is that it can create only a single instance of it. If we are instantiating the class once more, it remembers that there was an instance and it gives you back that instance. So it's imagine a situation when you need to have the same stuff throughout your code base that remembers the different parts of the code base that used it already. A good way to think about it is that imagine a library that you are importing into your system, and then you use it once, for example, at this src slash index .js level. You instantiate some stuff, and then suddenly, whenever you import it somewhere deeper inside your code base, you have the same configurations already, but you're not configuring it. So a typical way to think about it is that a typical way of importing stuff inside your library is that the Webpack, for example, goes to the node modules, imports the parts of code that you're using inside the file that actually uses it, and then it's like a copy. But with the singleton pattern, you are essentially doing the same thing, but the library that uses the singleton pattern, that it remembers that it is already instantiated, and that every time it's imported inside your project, it's already remembering the configuration. So let's go into the nice definition. So singleton pattern simply prevents our class from creating more than one instance of the blueprint we define. Alternative, the singleton pattern is thus known because it restricts instantiation of a class with a single object. Classically, the singleton pattern can be implemented by creating a class with a method that creates a new instance of the class if one doesn't exist. If in the event it is already existing, it simply returns a reference. So every time you see the definition like this or any other pattern, you just follow the definition, trying to use the language features, like whenever language you're writing in, because the patterns are not, they are language agnostic. So you just write the definition word by word and using your language of choice. So the same goes to my instance class. So we have a variable, the instance, and we are actually having this instance variable outside of all the code we're using. And this instance variable is there just to be reused throughout the calls of our singleton class. And we're just checking if it's not null or if it's like empty. And if it's not, we're returning it. And if it's empty, that means this is the first time the singleton car is called. So we instantiate it and then return it to the instance like we're remembering it. So this is it. Every time I try to define a different set of cars, it just returns the same thing. So if we go and try to look for the single car entity, for example, basically they're gonna be the same. So singleton Honda and singleton Civic, they're gonna be the same object, and that means they're all going to have the same thing written down in the class methods. Let's check it out. So as I mentioned, this website has some cool features built into it to help me give you this lecture. So the console, yes, and then the singleton pattern. So the entity is singleton car, and the entity is the same. So V6, V6. However, we define the V8, and it should have been V8 instead of V6 in both of the cases, or in the second case. But in both of the cases, we have V6. So the instance is not created, unlike we see in the code, because we're using the same instance that we remembered already. This is all about singleton pattern. So what's next? Let's keep it open. The next up, we are stepping above one step, pardon the repetition, but the factory pattern is something that spits out different creation methods for a set of conditions. So we have a creator. Also, I should mention that all these pictures, they are officially mentioned, like some of them mentioned in the Eddie Osmani explanation. And these pictures are kind of confusing to understand first, but then when you are when you're used to the actual words they use and the types of arrows they use, it becomes kind of easy. So we have a creator and the concrete creator. The concrete means the actual class or the prototype or the thing that will create some products. So when I have a template, for example, this is a template and this is the concrete object that gets created by the template. So you think of this as a creator and this is a concrete object. So they have this word concrete every time they mention something that is creating another thing. So we have a factory that has some operations and factory methods inside of it. It has some conditions, and once one of the conditions is met, it returns some concrete class that can be used. A factory is is great when you want to create a mechanism to create other objects. This can be useful when you want a factory to handle most of your classes and then simply use this factory method to create new objects. Alternative, new factory pattern is another creational pattern concerned with notion of creating objects. Where different from the other patterns in its category is that it doesn't explicitly require the use of constructor. Instead, a factory can provide a generic interface for creating objects where we can specify the type of factory objects we wish to be created. So the input is that we triggering a factory that like give me something, and then as the output we expect an actual object. So it's like one step further from the prototype class where we trigger the prototype and it just gives us the same kinds of objects every time, and we are not in control of what type of object it gives us. We're just using a concrete class or concrete prototype. And in the factory is like a nameless thing. We just go and say, factory, give me milk, and it gives you a milk object. Or we say, give me, example, I don't know, cheese, and gives you a cheese object. So the factory knows about how to create those objects. Inside a factory, there are a number of conditions. And when we say we want cheese, it just returns you new cheese class instance. So let's take a look at the code. Okay, so the factory. So we have a cool car factory that creates cool cars. And then we have a factory that gets it has a method. It doesn't have a constructor, as in contrast to a typical class. So we know that we are not using new keyword with that. So with car factory, we just have a object that has one field, create car, and it expects us to provide a type. And based on that type, we are returning instances of different classes. So instead of using the cool car class directly with and providing it with those configurations. We are just saying, hey, I just want a Mazda and I don't really care about the configuration, so give me some, and it just gives it you back. And this is how we use it. We initialize it. You see, there's no constructor, I should mention. And then we use those methods that return the actual objects. So we're still dealing with objects, but we are one step further. We're abstracting away. It's like a instead of writing JavaScript and accessing the DOM, you just say React, just draw something to the screen, and I just want to handle the logic. So, and the last one in this category is the abstract factory. Abstract factory is one step above the factory. So remember, factories are used to create different types of objects using their classes. So the abstract factory is a step further, is the factory that creates other factories that gets used by the user later to create the instances of our object. So let's dive. Firstly, let's go into the definition. So the abstract factory pattern allows you to abstract factories themselves and enable you to create multiple factories, classes, etc. Alternative, abstract factory pattern aims to encapsulate a group of individual factories with a common goal. It separates the details of implementation of a set of objects. So the abstract factories, like, so I said a factory could be a milk factory or any like food factory, let's just say, because I can ask the food factory to give me some milk or then cheese and any other food. I can ask it to give me something like, give me a car. The abstract factory is like a whole heavy production, I don't know, department of the whole country. Just go and ask, hey, department, give me food, and goes to the factory that gives food and just gives the food to the people. Or then say the demand is rising for cars, and the department of that particular country just goes to the factory that produces cars and gives orders to produce different sets of cars. So that means instead of having one class and one factory, we're going to have several factories in the abstract factory. And it's like this. So we have a war car factory, and the factory, or we have a class, war car class, and then the factory that produces war cars like BMP or tank or nothing at all, as it should be, world peace everywhere. So then peace car, and the peace car factory that produces like civic cars, Mazda, BMW, etc. And then we have the abstract factory. We can say, okay, so the country is now in war, and the abstract factory returns you war cars instead, or like not just a war car, but we are defining this abstract factory as a function, and we provide the type of car you want and the car itself. So you say like a war car and a tank, and this gives you a nice control without actually knowing or without actually controlling how it's defined underneath. So the creational patterns in the end are patterns that build up on the essence of creating something, either the smallest piece of code like an object or a large systems like abstract factories. Okay, and we're done with the creational patterns. Next, go structural patterns. And before that, I'm going to ask you if you have any questions. 43 minutes for like a half of the lecture, I suppose. It's going to be a long one. So, if no questions, structural patterns are the next one. And these patterns explain how to assemble objects and classes into larger structures while keeping these structures flexible and efficient. So we already have a set of objects, and we have some kind of factories and abstract factories that create different kind of like abstractions on top of those objects. But how do we actually manage them? How do we put them in structure? And these structural patterns are not just about how we defining stuff in our files, but how we actually manage the files. So one thing to know is like one of you mentioned on one of the previous lectures about the MVC pattern. So the MVC pattern, like module view control, is also a pattern. As far as I remember, it's like a part of the structural patterns because it involves thinking about how to organize files inside your project and the relationship between them. So as you know, the MVC pattern denotes that view is just a passive thing that receives some data and is from the model and is controlled like the behavior by the controller. And the model is never interacted directly from the view, or I should say, there are some differences in MVC, like MVVM or MVVP, that denote those relationship between the module view and controller. But the overall focus is how different files, or how different parts of the system interact between themselves, like their organization. That's why I have this picture of people in the typical corporate structure. And that's why structural patterns contain the following patterns. So a module pattern, you might not realize, but you're already using a module pattern in your daily life, having written some import statements or export statements in your React projects. This is a module pattern essentially. However, it goes back to a specific implementation of JavaScript functions or their scope thing, and that's what we're going to cover in the module pattern. So then the mixing pattern, that is about how you organize the codes into a reusable like pieces. So with the object-oriented programming, we have this inheritance notion, and the inheritance, as I mentioned already, is mostly about the builder pattern. But in JavaScript, we don't have like that many inheritance thing going on. We have more of a, especially with React, more of a composition part of things. So we have lots of functions and objects that should share some functions, and then some objects that should share one function from that object, and then another set of functions from the other object. So the mixing pattern is all about how we can share those functions between different objects. The facade pattern, that's all about typically an API for your modules. So instead of actually having lots of methods used and know about how those methods are written in each of the objects, you create some facade, like in some of the countries, not to mention which one of them, instead of actually fixing some buildings, some old buildings, government could just place pictures of a nice looking buildings in top of in front of those buildings, so that when people arrive next to those buildings, they see a beautiful facade, as you say. Or a more conventional example is exactly a facade of the building. That thing that faces the road, or like the entrance to the building, is, and it's typically most beautiful part of the building because it's like the front of the building. And we could say that the front end and the back end are a typical example of the facade pattern. So the facade is a beautiful UI interface to the complex backend logic. Flyweight pattern, a pattern of reusing some logic inside our project. And the decorator pattern, that is mostly like mixing pattern, but with a different like notion, a different goal in mind. So, okay, let's go to the code. Firstly, let's look at the beautiful pictures of the structural patterns. And first of all, we have a module pattern. So a module pattern is all about having some structure inside your files, reusing those files between each other, and exporting something from the files. Just definition is as follows. The module pattern is used to further emulate the concept of classes in such a way that we're able to include both public private methods and variables inside a single object, thus shielding particular paths from the global scope. And I'm not going to read all this, it's just too much. So when I mentioned that the module pattern is mostly about the modules that are widely known for JavaScript developers, to JavaScript developers, because we use them in our everyday life. In the object-oriented programming, what the Gang of Four meant when they introduced the module pattern is the notion that some of the methods of a class, of a particular class, could be private and some of them should be public. Since to some extent we don't have such capabilities in the classes of JavaScript, however, what we do have is the ability to hide something from the outside world by using the API of a particular module. So what I mean by this, imagine we have an object, like a very large object, as we see, and we're using some of his or its methods, and we're expecting to be able to call those methods and not really without even like writing those functions. So we're knowing that the function getName is inside the object module, and we're just calling it, and we hope that the module will be using, or the function will be using some of the methods or properties of that object. So it's all about like how we implement the object, right? So what we have here is that, for example, getName returns some particular name. So in JavaScript, we use this keyword for that, so that when we're calling the getName using the object module before the dot, we are referencing the same thing, and we are outputting the object name, for example. However, you know that when I write code like this, I cannot hide anything from the outside. So every method that I write, if a user or a programmer is given the object module, he or she can use the methods of their object. Even the VS Code tries to say something about it. So how do you actually hide stuff? For example, just imagine we're having an ethi. So what's an ethi? Ethi is an immediately invoked functional expression, and your module system of choice, CommonJS or maybe ES6 import exports, they started from a typical function. So a module in JavaScript is based on the function. And what I mean by this is that when we import something inside, we are executing an ethi that returns some stuff inside, and it could be an object, it could be a single thing. However, what is returned to the ethi module variable from the function itself is defined by us, and we define it like this. So since it's a typical function, we're just expecting that something gets returned to the ethi module, and we are using a return thing. So even if we define something in here, it's just kept in closure, and if we're not returning it from the function, we're not able to access it from the outside world. So that's what happens. That's how modules can have their private methods and so-called API for interaction. And this is all about the private-public relationship in the module pattern. Okay, so the next one, the next one is mixing pattern. So the mixing pattern, as I mentioned already, is the situation when we need to have a new entity or the object that needs to have some of the methods from the already created object from one place and then some methods from other place. If we're talking about a typical case of inheritance, we should inherit those methods from both of their objects. But not every programming language um, supports multiple inheritance. So we are down with the problem. How do we get those methods without writing them again? And the mixing pattern is all about that. So mixings are a great way to mix functions and instances of a class after they've been created. We can look at the inheriting from mixing as a means of collecting functionality through extensions. Each new object we define has a prototype from which it can inherit further properties. Prototypes can inherit from other objects' prototypes, but even more importantly, can define properties for any number of object instances. So, straight into the code, because without the code, patterns are merely just a facade. Okay, so we have one class that has some drive method. Then we have another class, my mixing class. And from that class, as you can see, we're creating some kind of car, and then we mixing, or I should say, creating a new object from the car prototype and inserting some of the properties of my mixing, thus giving the car entity or car instance the ability to call the methods without even having them in the first place. But this magic able is able because the JavaScript prototypes some templates as the classes in other languages. However, the idea is that we're just like a composition thing. We're sharing some classes directly. So if I were to just, instead of using object assign, just use some methods and rebind them into a new object, I would get the same thing. So again, the mixing pattern is using a already created objects or instances, extend them by a new thing. And a mixing in this context is an object that extends the capabilities of other objects. So when we hear that we're importing a mixing and then extending some object or some class with a mixing, all they means that the mixing is an object with some set of classes that we define, and we're extending in runtime the already created instance with it. So a mix in, kind of easy to remember. Then we have a facade pattern, and according to the definition, the facade pattern provides a convenient higher-level interface to a large body of code, hiding its true underlying complexity. Think of it as simplifying the API being presented to other developers, something that almost always improves usability. So the facade, imagine a situation that you're writing a really complex system and you've already done a great job for among your developers, and you've created a really complex system, but then suddenly your business model changes and you need to provide an API to the outside world and start gathering the money from other people who are going to use your API. So instead of exposing the whole mess that you created, and you know how it looks and how it works, but other people might not be as smart as you, or might have more time on their hands to write a good code, So instead of giving them the raw API or raw system, you cover the whole thing with the set of rules or the set of things that are exposed, much like you did with a module pattern, where you wrote like lots of functions, and then from the if just returns a fixed set of functions. Kind of like this, but the intent is not to hide stuff inside, but give, for example, better names or combine several function calls into one function that gets the job done. So the facade pattern is all about a um, hiding the exact implementation, not the hiding because you want something hidden. So it kind of mixed. So let's go into the code. Facade pattern. Okay. So as I mentioned, combined with a module pattern, so we have a set of private methods, and we're returning something like a function from the facade module, as you can see here, that combines several methods inside of it and gets the job done. Well, we are not aware of it. We're just given the, for example, a TypeScript definition or maybe VS Code definition that this module has facade, and it expects some arguments, and maybe some documentation says, okay, just go create a object and give it to the facade so that the job will be done and the properties are run and value. And you don't actually know how those values are going to be used. And this is exactly the way or exactly the goal of a facade pattern. So in the insights, you're combined with the module pattern. So you're returning a object, a facade. So this object is the actual facade, and it uses some private methods that are not exposed to the outside world. And these private methods are as follows. They do something useful. And before that, for example, we have a standalone function, as you might be familiar with add event listener. So it expects some reference to an object or a document, for example. It expects you to give a type of event that's going to happen and what you need to do about it. So it's like a facade on top of the add event listener and attach event and some kind of another thing. So most of the time, this facade will be used when we want to abstract away the actual realization or how we do events in the system. Either we attach them directly to the element on click event, or we attach them like attach event. I believe it's the Internet Explorer thing, or we use just a vanilla way of attaching the event. So, and all it's done with a one function call. You don't actually know how it's implemented inside. So it's kind of like those 4 pillars of OOP, where you abstract something away, but the intent is to make something like really beautiful and robust instead of providing people with lots of ways to doing the same thing. Okay. Now we have a flyweight pattern. As I mentioned, the flyweight pattern is a classical structural solution for optimizing code that is repetitive, slow, and inefficiently shares data. So without going into lots of detail, flyweight is directly as the name implies, flyweight, a really light implementation of something, light object. So into the code itself, the flyweight is mostly about reusing the code that's already is done. So I think if you want to dive deeper into the implementation details, you can go after the lecture. But the thing is, imagine we have lots of operations that's going on that do essentially one thing. So 1 million times create an object. Create an object, and we're providing some properties to it and maybe some random elements. Basically, what we're doing is that we're creating a million objects essentially. However, for the system to work, do we actually need those objects? Do we actually need all of them? And trust me, when I wrote the code, when I executed the first time without the Flyweight pattern applied, my browser was like stuttered for a couple of seconds before it actually rendered the thing. I don't know if it's my like the system that I'm running or this is actually a really hard thing to do. But the thing is, one of the optimization is that look, there are just a number of objects or number of properties inside each object, and since it's a random thing, probably some of the objects will have the same kind of like set of properties and with the same values. So instead of actually creating all those objects separately and storing them in memory, maybe I can create just a fixed number of objects with all of the permutations and then remember how much objects I actually created and just returning something based on a really unique value. So what I'm saying is that instead of creating a set of objects with repeated objects or possibility of repeated objects, think of arrays, for example, where we could have the same values. We can have a set, like a mathematical set, where we don't have a repeating values. However, we still have the data when we just need to remember how much actual objects we need to have. So the Flyweight pattern is all about that. So um, the essence is that we are trying to find if the newly created ID of an object or the object we're trying to create is already there. And if it's not, if it is, we are creating it. Or if it's the same object, the same ID, we're just returning the already created one. So just with a couple of if statements, we're reducing the actual number of objects in our system from all the possible things to the actual number of permutations in our system. Kind of confusing, might be. Just take a look at the code. It will be easier for you. The patterns are all about the abstractions in which you think and the reasoning behind all of these patterns. So as we see in the picture, we have some kind of factory, and then the client asked the factory to create an object, and this object is deciding if it's already created object or if it's like a shared one or a new one. And the last one in this structural section is a decorator pattern. So a decorator is something that might be familiar to you. For example, if you come from the AngularJS or maybe React.js with some additional whistles and blows. Basically, when you have a component, a React component, and you want that component to be extended in some way, but you still want to reuse the same component, you can have a higher order component that wraps around the component that you already created and adds inside that component or the end result some additional features. So the decorator pattern is all about following this set of high order component plus a original component structure, but with the vanilla JavaScript or vanilla C, C++ languages. So the official definition is as follows. Decorators offer the ability to add behavior to existing classes in a system dynamically. The idea was that the decoration itself wasn't essential to the base functionality of the class. Otherwise, it would be backed into the superclass itself. So yeah, if you want to be able to write a system and without polluting all the different kinds of systems with the same behavior, you can extend it into a decorator and use it every time you want to for it to be used. Um, Kind of like mixing, some of you might think, and you would be right. This is a very closely related pattern. However, the actual the focus and the moment that the whole thing is created is different. When we are talking about mixing, is that we're using some already created stuff and we're creating a new thing out of it, or like we're um, no, we are. This is all about the decorator. So the mixing is, or we're mixing some kind of additional behavior to the already created object. So we're mixing inside of it, and the decorator is having an object and then creating a new object out of it with additional features, sort of like build a class would in the right runtime without like actual creating. So remember that the patterns are divided into several like categories, and we need to be aware of the creation phase or runtime phase or the algorithm phase, and the structural patterns are about the runtime phase. So in the runtime, already created objects, and we need to create another one. We either using the creational patterns, but we are already in runtime, so we need a different set of rules. And the runtime rules from the structural patterns are the use mixing to mix some behavior inside the same object, or use the decorator pattern to create a new object with additional behaviors. So go to the decorator. So decorating constructors and decorating objects. We can have, for example, let's just look at the decorating object. So function is a typical object, and we have some additional function. And a decorator is essentially a function that returns a function. So you might think of it a higher order function or higher order component, as I already mentioned. For example, in the Redux world, the connect function, sort of like a high order component or high order function to be precise, and it uses the decorator pattern. So every time you see something like this, where you have a function that is called and then immediately called a second time, this is most of the time a decorator pattern. So what we do is that in the MacBook world, we are creating the instance of MacBook and then use the decorated function that expects an instance of MacBook and add some additional features to that. So change cost expects the actual MacBook. It produces, or like it calls the cost method, and then it returns or overrides the method with the addition that we are specifying. So if the addition is the default one, 997, we have this value inside of the change cost, and then we additionally provide a new thing. So these memory, engraving, and insurance stuff, they all produce new stuff based on the instance that we provided with a function that we provided. So the instance is getting decorated with the function or the decorator, and thus giving us a new value. So the value is given us only when we call it, and we call it by providing a function that is wrapped with decorator. Kind of confusing from the first glance, but think of reusing in functional programming. So what you see here is basically a functional programming where we have a defined set of functions, and then we're combining those functions in some like nice way using a function as a first class citizens to create a new set of functions. And those functions will have some features already defined and some features need to be provided, and thus giving us different behavior based on the decoration. So thus we are wrapping with the structural patterns. And okay, do you have any questions? Because we have like we're past 1 hour, and you might be already swarmed with the questions. If not, we can continue. Okay, no questions so far. And we're going to the behavior patterns. But first of all, the presentation. So the behavior patterns. So we're done with the creation step. We created all the objects, or the system is able to create all the objects it needs. We're done with the file structure. We agreed on how we're going to combine those files together using some module patterns. But how do we actually solve problems inside our files? How do we actually use the instances created on the creational step and do some nice, robust business logic with it? So behavioral patterns are concerned with algorithms and the assignment of responsibilities between objects. A really nice way of thinking about behavior patterns, for example, take a look at the React component. The React components are defined in a specific way. For example, if we take a class React component, where we have ability to call different lifecycle hooks. Like we have a state and we have some kind of rendering logic. All is given to us. But how do people did the same thing before React? How do people did like stuff that React does for us before React was invented, or any other framework was invented, even jQuery? They were struggling, and they had to use or rely on using the behavioral patterns. Take a look at the functional, or like the state pattern. So the state, the ability to store something inside the instance. So the ability to store something inside the instance is a pattern. Sorry, I just unplugged myself. So can someone write something in the chat so that I know that I'm still live? Anything? Okay, plus. Thanks. So the state pattern that I mentioned is the thing that is used by React, for example, in the class components, and it's all about having some object with some functions or like methods inside of an object, and then having some external outside of those methods object called state that they can use. So this is the typical way. Before that, we had to say the long lines that I just mentioned to try to explain that I'm going to use a state pattern. So again, the behavioral patterns are the ways we organize the code. And we have the observer pattern, for example, that's very popular with AngularJS developers because they have the RxJS library. And the observer is the thing that notifies any other code about the stuff that's happening inside the observable area or observable object. A chain of responsibility pattern is the thing that ensures that a set of behaviors is executed in a specified order. For example, if something happens in the system, if I call, for example, I don't know, some kind of service, like I pay for stuff, I have several different accounts, I say that I prefer to pay with this bank, but if I'm not able to pay with this bank for any reason, then use that one. So, like, we're providing a way for the thing to execute stuff inside the system. And the iterator pattern. Um, I've already given a lecture about the iterators and generators. So the iterator pattern is using the same kind of things, uh, but gives it like a name. So the iterator is something that we go over and over again. And believe it or not, before the Gang of Four, we had to use just some abstract ways to explain that we need to go and repeat some stuff again and again. They gave it a name, iterator, and that's why the JavaScript itself has the iterator. If they given it like a for pattern or do while pattern, then we would have something like this in the JavaScript language. So before the iterator pattern, we didn't have the ability to nicely say that we want to have something go over the collection of data and do something with it. So iterate. The strategy pattern. The strategy pattern is all about choosing a strategy. For example, like a warrior or maybe the general that, depending on the situation, it chooses to go either full into battle, to charge, or retreat. So that's how some of the libraries that you might use work. Memento pattern. Memento is essentially giving a way to a developer or maybe a system to remember the previous state. For example, kind of like a component having changed its state and having access to a previous state and the current state and comparing them together. So Memento is something like this, or maybe a way to organize our code in such a way that if something happens, we have a default state available for us, a fail-safe mechanism. The mediator pattern. Mediator pattern is, for example, if you see fancy drawings of the architecture of some kind, and you see two squares interacting with each other directly, this is usually a bad pattern because they know about each other. Those two squares, the blocks of, I don't know, systems, they know about each other. And a typical way to improve such architecture is to use something like a square in the middle, so that those two squares from before, they have no idea about the existence of each other, but they know about the one thing, the mediator, that can handle all of this stuff. It's like having lots of people work for you, but they have no idea about them being like there. And then every time something happens or they need some help from other people, they just go to you and ask for, like, can you provide me a way to serve? For example, or maybe a telephone line that was organized in the previous century. They had people not knowing phone numbers of other people, and they just had a single number of like a telephone station, and they call the telephone station and say, I want that address. Can you put me through? So this is all about the mediator pattern. And the command pattern is like, again, the general and the army. And the army is expecting the general to give them a command of what to do. And it's like an object that has different methods, like retreat or charge. It just expects some other external system to say what to do. And the general can be given an input like, okay, the weather is good, so we need to go and invade some cool country. But the thing is, it's just too long, and it uses some kind of set of already known commands, or maybe it can have this exactly one command, like give command, And the give command function just expects a string that indicates what command to do. And this is all that general needs to know. All the people under the general, under his rule, will be like giving that command, and they will go and do their business, do their work. So actually organize the whole army to do the command. And the general doesn't really need to know how people in the army will be retreating or charging. This is all about the command part. Okay. Too much talk in this lecture, and we need to give it some code examples. So the first start with the observer pattern. The observer pattern is a design pattern in which an object maintains a list of objects depending on it, automatically notifying them of any changes to state. So as I said, we have some observer that observes the subject. For each observer dot update, and the observer gets the instant update of something happened in the system. And this works in a loop. So a typical example of the observer would be something like this. So in the observer pattern, we have like several things that needs to be remembered, several definitions like subject or a publisher. So the subject is actually the object that gets something delivered. So it publishes some events or notify, as you can see. And observers are those like entities that needs to be notified. So they observe or subscribe. So observer pattern is a typical publish subscribe method. When observers or subscribers subscribe using one of the methods of the publisher or subscriber, filling the list of subscribers that the publisher or subject needs to notify if something happens. So you can see a typical way to organize it is to have a publisher give out a API that enables people to, or like objects to go inside his local state pattern array observer and unsubscribe to be deleted from that array. And then when something happens, we just, since we have an array of objects, and objects are given the links to the objects, so they transferred using a link instead of a copy. So we're able to go through the list of observers and do something with it. Each observer is a subscriber or an observer, and it has an ability to receive something, the data, for example. So observer is the stuff that subscribed to some notification. For example, you subscribe to some channel, so the observer, you have an ability to be notified when something happens. So this is your ability to be notified. And for example, you go and watch the videos or report the news. And the YouTube channel, or YouTube itself, is the publisher, or YouTube channel is the publisher in that case. It has some list of observers or you subscribers, and it can notify you if something like a new video is added. So again, observer pattern, two types of objects that one object collects observers, and the other object is actually gives the ability to be called once something has happened. So in this example, I have the news publisher and different, for example, different kinds of medias or newspapers that can do stuff with it. And we init it, and then we subscribe those newspapers to the actual news, and then we do something with it. So we're using one call, one notify call. We actually giving two newspapers something to do about it. So if we again go to the code and go to the first statement, you see that we get New York and the Guardian execute the same thing. However, we just called it once. So a very nice pattern, the observer pattern, that is used in a number of systems, trust me. Then we have the state pattern. As I already mentioned, the state pattern is a behavior design pattern that allows an object to alter its behavior based on the changes to its internal state. So think of it as a React component that gets something based on the state inside. And we'll look at the picture. We have the context that like system says that something has happened. We have a state object that stores all the stuff inside of it, and then the concrete state just gets like feeded into the whole system. In a React component, we won't know exactly how many states we're going to have. We can have like a default state and then something's changing the state. But for example, in the state machine world, and like you can Google it, state machines are like a set of logic that can be described as a set of states. The state pattern is used heavily. So in general, whenever you need to save something and reuse it for a period of time, you are talking about the state. So state looks something like this. Oh shit, that's a long one. So a number of objects that we are using, like the prototype from the creational objects, and then a builder pattern from the, again, creational patterns, yellow, green, and red light, and then the traffic light. So this is a big class that has this public internally defined state object, like this states, or it could be like class-based component in the React and the constructor or emitted constructor, and it has a different states and has the ability to store the current state from the state object and then change those states inside of it. So again, class pattern is really easy to recognize. If we have a class, we are basically having something stored in the constructor in the this dot something keyword, and we're changing the behavior of the internal methods based on this dot states word inside of it. Or in the case of objects, again, we have a set of objects that can do stuff about themselves, and then a stateful object that stores the different states inside of it and then uses the states. So just remember that before the patterns, we have no ability to say like states or something like this easily, and a way to recreate it. So state pattern, the same thing they use in the React, is one of the patterns from the gang of 4 patterns. Change of responsibility. Design pattern separates the sender of the request from the receiver. So again, when I, a customer, want to use a system, and I don't really care about how the system will handle my response, and for example, which bank will receive my response, but I do care that the system executes some set of functions in a specified way, or the bank self-cares that I get charged with from my bank account in a set of rules. So the banking industry uses some really strong strong ways to define the operations that need to be done in a system. So, and they rely on the chain of responsibility pattern. And in the code, it actually looks a bit more straightforward than you might think. Yeah, lots of code, but essentially what it does is that we have a payment system. So let's just go down so we can see. So we have a payment system. We initialize some objects, for example, like Kiwi objects or video objects or PayPal objects using some kind of preset account object. And we say that, we have these balances inside of each object. But each object is able to be chained to other objects, indicating which one should be charged next. For example, we say that we want to pay with Visa. We pay 400. In the Visa object, we don't have such amounts. But we say, so if I don't have such money in my Visa object, I should then go and try to pay with PayPal. And if the PayPal doesn't have such amount, go and do something with Kiwi. So the way that we organize this is called the chain of responsibility. So first, the Visa object is responsible for payment operation, then the PayPal object, and then the Kiwi object. And I denote the whole thing with the account object. So account object is an object that is able to be chained. So we provide it with the handler, the next one that's going to be paying, and we store it in the state using the state pattern in the this.handler. And then every time we call the pay, we are using not a concrete implementation of our object, but the stored one. And we store it inside the handler. So we're kind of using this account object, we're kind of abstracted away from who's going to be paying. We just need to make sure that the payment is possible and we know which one will be next. So the next function in the chain of responsibility is one of those things that are necessary to organize the chain. So again, chain of responsibility is having an abstract action to be executed in order of responsibility that we construct using with the next keyword. Okay. The iterator, again. The iterator is a design pattern in which iterators, objects that allow us to traverse through all the elements of collection, access the elements of an aggregated object sequentially without needing to expose its underlying form. So a typical for loop is like kind of an iterator. So we need to have a special object or like each object in our collection to be able to be called using a predefined set of methods. So it recognizes or has the methods inside of it, and then can be changed to another one so that we can have an iteration happening. And a iterator is the same thing that we created, like mostly the same thing that we created in the iteration or like iterables lecture. So, okay, let's have a chat room. And then let's have a chat room register different users in the chat room. And then those users will be sending some messages. And we expect the system, the chat room, to deliver the message to all the registered users using the same pattern that we discussed already, like chain of responsibility and the observer pattern. So inside of this, oh, sorry, it's a mediator. Yeah. Yeah, that's what I'm looking for. Oh, this lecture is a really long one. So we discussed the iterators already. We know that to create an iterator, you need to use a symbol iterator, and the iterator itself will be a special kind of object that will have a next, that will have a iterator object returned, and the next keyword inside of it that knows how to increment the internal state that is kept, and then say when it's done. And usually when we use the iterator objects, we go like this. So the iterator pattern is, so this is an implementation of the iterator pattern in JavaScript world. In other languages, it could be written in a different way. But the main thing among those languages, even if it's not a JavaScript language, is this notion of next keyword. So we need to have an ability to write a special kind of object that could be called using .next or like next method, and then expect that it will go through some like collection of data. For example, in this case, we're not giving it a collection. We're actually just outputting the set of like integer values. So for your notion, the iterables in JavaScript are following a pattern that I mentioned in that lecture. And this is a iterator pattern. Next, we have a strategy pattern. So we have some kind of ability to have an object to call a very vague method, like do something, and then that object, based on the input to the do something method, will decide what needs to be done inside of it. So let's go to the definition. The strategy pattern encapsulates alternative algorithms for a particular task. It allows a method to be swapped out at the runtime by any other method strategy without the client realizing it. So the strategy is all about a set of methods that gets executed by providing a kind of a vague method, like we have here, calculate the shipping cost, for example, giving the goods. But the actual implementation of this calculate algorithm will be based on the strategy that we define. So in the runtime, whenever something in the system calls and sets the different strategy, the entire application that uses a vaguely defined method will be behaving in a different fashion. How do we do that? So in each of the objects, as you see, UPS, DHL, FedEx, we have this calculate method. So if we define the calculate methods for each of the objects, and then provide these objects to be used inside the shipping instance, and the shipping instance in the calculate method will be just calling the calculate method from the provided object, we're good to go. And this is what happening in the shipping object. So shipping, when we create it and set the strategy, sets the, using a state pattern, sets the company, like DHL, UPS and stuff, inside the memory, inside of its state. And then in the calculate method, when we vaguely define, we calling the this.company calculate method, but providing the values. So again, the strategy pattern is about the algorithm that gets used under in the underlying system. Okay, memento. Again, in the memento pattern, we have a set of like definitions that are defined in the whole pattern thing. The caretaker in the memento pattern is the actual thing that holds the notion of the state, The memento is the object that is able to store something inside the caretaker, and the originator is like that thing that creates the memento object. So the memento pattern provides a temporary storage as well as restoration of an object. The mechanism in which you store the object state depends on the required duration of the persistence, which may vary. You could view a database as an implementation of the memento design pattern in which objects are persisted and restored. So yeah, one thing to note that these patterns are behavior patterns. I said that they're not spanning outside of the codes that you write. However, the systems that are surrounding us might be based, or the patterns might be based on those systems. So we can have in our application a memory storage, which is our variables, a cache storage in, for example, a Redis cache storage, which is again something that is more persistent than memory, but not exactly as much as the third option, a database, which is persisting our data for as long as like the database lives. So the memento pattern is the pattern of persisting data. It's different from the state pattern because the state pattern is unique to the instance, but the memento pattern is shared between instances. And what I mean by this is that we go to the memento pattern, and we see that this is the originator, the stuff that creates the state, so the memento. As you can see, it has some kind of the state object, this state, and it uses the state pattern inside of itself. It can hydrate the state, so it can receive a new object, or it can hydrate the state by like giving a stored object, or it can dehydrate, meaning it can renew the stored state from the outside. So the hydrate and dehydrate is are also like some definitions that are coming from the memento pattern itself. So the originator is that the actual storage that can give back data or can receive a new set of data, and it lives outside of our the thing that uses those objects. The caretaker is an object that can have those mementos or like different set of places. For example, the caretaker for our application can store data inside the memory, inside the like the cache, Redis cache, or a database. And when we add some data, for example, or add the storage option for our application, we're adding a key and the actual option to the system. Or we can get the key so that we can use that option. So we have a mic, a human that has some properties. They are default properties. And what we call the init method, we're calling the originator method. So we're just setting the default storage. And then we have a caretaker, that is an instance of caretaker. And then a caretaker can store the state of our system. So we have a local, for example, this can be one, or this can be like local or cache or database name, and we store the data. So we're giving back the data to the caretaker. And when we change something in the system, and the changed value is available to us, and the object is changed, but we can change the object back from the caretaker. So the caretaker is actually the one that stores the data inside of it using different keys. So this is like a state pattern, but external to the actual object. Okay. Then we have a mediator pattern. The mediator pattern, as you see in the picture, we have a number of uh, colleagues that can do something, and they have a notion of the mediator, but they have no notion of other colleagues existing. A very strange situation, however, this is a pattern, and it's based on the loosely coupling the system. So the mediator is a behavioral design pattern that allows us to expose a unified interface through which the different parts of the system may communicate. So lots of objects, one object in between that holds, using a state pattern, a notion of all the other objects in the system inside of itself. And whenever one object wants to interact with another one, they are calling the mediator, giving all the data it needs or they need for the communication, and the mediator decides which one is going to be called. So let's go to the mediator. Yeah, that's what we're going to discuss. So we register all the objects. So the chat room is the actual mediator. We register all the objects, and then we using the whole thing by, for example, the mat object, which is a colleague, it sends something. So in the send method, we know we have the notion of the chat room, but we have no notion about the wheel or Paul or any other thing. Just imagine that you, as a user of a chat or Telegram, for example, will be storing inside your system all other people in the world that you can communicate with. It's not really possible. So the Telegram or any other methods of communication, Skype or Teams, they have this mediator button built inside of it, and they register users like in a typical registering system. And whenever you send a message, the mediator knows how to deliver and to whom to deliver. So let's go and look at the methods. So the chat room, our mediator. As I said, it has a limit, a way to store the participants or the colleagues in the picture. And we do this by registering people. So we're registering by participant's name, for example. And to each participant, we give a notion of the chat room itself. So it's kind of not really a nice way to write code. I mean, like giving an object from the outside world and modifying its one of its fields, but at least for this example, it works. And then the chat room has the ability to send, and it sends messages to, like for example, private messages when we define a name, or to everyone, like the public messages when we go through the list of participants, calling each participant by the receive method. So that means whenever we see a participant using .send, the participant actually, they calling the chat room send. So why? Because the chat room has notion about the colleagues, but the participant doesn't. So, well, if you look at the code, you can actually understand that the participant through the chat room has the notion of the participant itself. That's why I'm saying that this particular implementation is not a really one-to-one to the mediator pattern. So in the typical system, we would not mutate the object with the chat room itself, because otherwise we will have all the participants inside of our participants. However, it illustrates the notion of sharing some kind of mediator between all the participants. And the last one, the command pattern. So the command pattern is mostly the same, like it looks kind of the same to the strategy pattern, but I need to mention that first, the strategy pattern is all about different implementation of the algorithm. For example, do stuff and we do stuff in a different sort of way in the runtime. We're not necessarily providing this way of do stuff. We're not saying do stuff this way. This is more like giving a system a command. So the command pattern is all about we specifying like what needs to be done and in what way. So a difference between the strategy pattern and a command pattern in that in the strategy pattern, we have a general that calls his officers and says, we need to retreat, and they do the business. In the command pattern, the general says, we need to retreat, and so go assemble your team, go to that place, and these guys should come from this way. So we're describing how we need need to be doing the operations. So the command pattern aims to encapsulate methods of invocation requests or operations into a single object and gives us the ability to both parameterize and pass method calls around that can be executed at our discretion. So again, if we were to just parameterize the objects, we would use some kind of implementation of strategy pattern, but we are also passing a method that should be called with those parameters, thus giving us the ability to call this pattern a command pattern. So this is like what it looks like. The client gives receiver a call for action, and then they can quick command to execute it. And the command pattern receives both actions. The concrete command receives the parameters, and then it executes it. And what is done in the command pattern is just the ability to invoke a given function and invoke it with the set of parameters that need to be passed. So command pattern, it basically looks like this. For example, let's just look at the usage. We have a car manager that has an execute method, a very vaguely called method, like it doesn't describe what needs to be done, but then we pass a parameter object inside of it, instead of like compare it to the strategy pattern where we have just like do stuff. We are calling some kind of executioner that doesn't know what to do and needs to be told what to do by us, and we give this in the parameters. So execute the arrange viewing with this payload. And then the actual implementation looks like this. So we have an execute function that receives an action with a type and payload, and it does stuff. I'm sure that it rings some bells inside your head. And yes, the command pattern is heavily, or the Redux, I should say, is heavily influenced by the command pattern. They use it, and the notion of actions, and the actions as objects that denotes what to do and with what parameters is taken from the command pattern. So yeah, and if you're interested, since I'm like done with the whole presentation and ran out of patterns that I wanted to share, I can go and Google stuff. For example, the Redux as a command pattern. You can see and the explanation behind the Redux and the command pattern, where we give the action as a type of what to do and with what data. And the passport.js, a library for authentication on the backend, if you're ever going to use passport.js, is a strategy pattern. And for example, let's look at the passport.js. I know it's not like outside of the things that we want to discuss, but it has a way of authenticating you using different providers. So for example, if you're seeing some logging methods where you can log in using Facebook, Google, or Twitter or GitHub. Essentially, in this whole system, it's like what function you're going to use for authentication. So, and when we're talking about the functions, we're talking about strategy patterns. Remember, we're not really aware of how those companies do authentication. Maybe they differ, but they probably differ with different tokens and stuff. But we are not telling the authentication method what to do. We're just noting that, hey, this is the pattern, the Facebook strategy. It has some ability for Passport to, okay, passport.use, here is the strategy you need to be using, a Facebook strategy, and it just does the magic. We don't really care about how it does it, and we're not saying how it does stuff. We just mention it. Or a more robust way to say it in the notion of Node.js is that, for example, if we define a route for our Facebook, we go and say Passport, use the Facebook authentication. So if you take a look at the passport.authenticate Facebook, it looks lots of like strategy that we're using here. So like passport, authenticate, using some data, but before that we specify that when you need to use the strategy pattern, this step is done under the hood when we do stuff in the passport. So yeah, that's it. That's a long lecture that I wanted to give you on the design patterns. There are some links at the end. Most of them I showed you already. Maybe if you get this presentation, you'll be able to click through. But this is a QA time. And if you were not satisfied with the amount of data that I showed you today, you can go to the Refactoring Guru/Design Patterns, a really nice way for inspiration for design patterns, and look at all the patterns that they're suggesting. They're kind of the same that I use. They also have some code examples. And if you are more into, they're more about like Java and C# and C++. They recently introduced TypeScript, but if you are a core JavaScript developer, you can go to my GitHub and search for JavaScript design patterns, and you'll have lots of stuff written here for you, and also with some miscellaneous patterns that I noticed in my career. But again, thanks for your attention. If you have any questions, so that was a nice lecture. We'll definitely come back to it. A lot of information. Yeah, I know. This is the last lecture, so it was like a bit longer than expected, and the whole design patterns thing, like area of knowledge, is a vast thing. When you are sometimes on the interview giving like a task to describe some of the patterns, and usually you're not describing each of the patterns in particular. You're just mentioning that there are several categories like creational, structural, and behavioral, and which patterns belong to which category. Exhaustive lecture. It's fair for the first to you, but yeah. Okay, so guys, if you have no question in particular, we can go and grab some nice tea and reflect on the lecture, the last lecture you'll have in this course. Yeah, to Mentors Day, yeah, but I mean the named lectures where you have like a dedicated stuff to be learned. Okay, so have a nice day. I will stop sharing and stop the recording. Bye.